Good evening, everyone, and I hope you guys are doing pretty good. This is going to be the day 20 of our 90 days SDET interview preparation series on YouTube. Firstly, I hope that you have completed all the old lectures properly. Now, here's one more task for you guys. See, if you are only watching these videos once, chances are during your main interviews, you are eventually going to forget all the things that you have learned. So make it a habit on revisiting all the old topics that you have studied with me. So dedicate one day, let's say Saturday or Sunday. Use that one day only to revisit all the old topics that you have studied with me. Okay? Now, in today's class, now we will be focusing on a very important scenario driven question. Now, a lot of time people say that Jatin cover a scenario driven questions, but the main problem that happens with covering scenario driven questions is if you are only looking at the workflow, okay, that I just say that this is the major problem in your project, you will not be able to present it properly in your main interviews because these days interviews are very technical first and they are going to grind you completely on a particular topic. It's 2026 and yet I see people are preparing for the interviews as if it is 2015 or 2016. Now, in 2015, if you would have just known basic Java, a little bit of Selenium WebDriver, TestNG, you would definitely get the job with a good package. But in 2026, if you just try to give the interviews with the same knowledge stack, it's not going to happen. I hope this part makes sense to everyone, and I hope everyone has felt this thing because this is something which is happening, and most of us are not even aware of this thing. So you just can't go with the basic knowledge of Java. You need to be good with design patterns. You need to have a complete knowledge on your CI pipeline. You need to understand how you will be scaling up your automation framework. Okay. A very simple interview question. What are the challenges that you have faced in your automation framework? If I ask you this particular question, okay, I know that most of the people will say that dynamic web element, XPath was pretty complicated. What else? Synchronization issue. These three things are very it's like everyone has just done a rote learning of this thing and they have just rectified the answer. Okay. And when we ask where you have faced this particular stuff, they really don't know where exactly the whole issue arises. Okay. Because it's all about what you have studied from, like one tutor to another tutor. And I really don't want those things for you guys because if you're going to do that, it's going to be very difficult to crack a good package. It's not going to happen. Anyways, in today's class, we will be focusing on this particular question only. What are the challenges that you have faced in your automation framework? But I am not going to talk about your dynamic locator or synchronization issue and all those stuff. We're going to focus on more engineering problem over here. So please make sure that you watch this particular video properly and if possible, make notes. Okay. The notes of this particular lecture, whatever the PPT that I'll be using for today, you will be finding in the YouTube Tech with Jatin membership. If you are interested, you can definitely check that stuff out. Now, let's get started. Over here, guys, this is my automation assignment. This is the framework that I had built for the SDET Foundation Masterclass. And over here, guys, I have this UI.test just to show you one of the tests. This is like how the test has been written. Now, over here, when you look at this test, assert equals homepage.go to login page, do login with whatever the credentials and assert that the name of the user is Jatin Sharma. Now, if you look at this particular test, this test, to be honest, is a Selenium test. But what do you notice over here? You will notice that I don't have any variable created here, right? There is no variables created inside the test method. Then you will also notice that there is no WebDriver code. Do you find anywhere that I have written any WebDriver code? It's not there. You'll be like, Arey Jatin, everyone writes the login test properly only. Let's see some other test. So let's go to add a new first address. It's just a 2 lines of code. Okay. You're not going to find anything related to your Selenium web driver. Now, whether you're working with Selenium WebDriver, whether you're working with APM, whether you're working with REST assured, or like any new library pops up, Playwright, Cypress, doesn't really matter. But the thing over here is the rules, the fundamentals don't change. Okay? Your test needs to be small. This is a very important thing. So whenever you are creating test, please make sure guys, you are writing the test which are small. Small tests are basically easy to maintain. Okay. In your test, you cannot have try catch, you cannot have for loop, you cannot have collections popping up, you cannot have any variable declarations and all those things. So why we don't have your loops, your conditional statements, your try catch and all? Because when you're talking about loops, your conditional statement, your try catch, they all introduce logic. Okay, that is a coding logic. But when we are talking about a test method, the test method which you see over here is just going to have test steps. Okay. So over here, look at this particular stuff. My account page, go to the home page address and save the address. This is what I would say is basically a step. That from one page, I'm going to some other page, and from there, I'm saving something. That's it. You'll be like, Jatin, you're creating a variable. This is for the students I had created it off. If you ask me, I wouldn't have created this temporary variable. I would have just copied it and I would have pasted it over here once and for all. So I really don't need this particular line. It's just for students understanding. Okay. Now, where is the whole Selenium WebDriver then? Whether you're using Selenium WebDriver, whether you're going to use APM or REST assured, they are going to be wrapped up in altogether different class. So if I go to the com.utility, this is where browser utility is there. And over here, guys, I have used my Selenium WebDriver. This is the only place where Selenium WebDriver is used. Okay. And technically, I am wrapping the Selenium WebDriver on my custom methods. So if I want to go to a particular page, generally you write driver.get, right? Or wd.get, whatever it is. But over here, I have created a method called go to website. You give me the URL. Internally, it is going to call your driver. Now, people are going to think that, Arey Jatin, you have written driver.get.get. What is this whole thing? We'll discuss that part. That is not the main issue. So, understand something that whenever you're using Selenium WebDriver, it has to be present in one class. Same goes for your APM. Same goes for your REST assured. Now, the problem statement that we have over here is how to make your Selenium framework thread safe. Okay. How to make your Selenium framework thread safe, or if you really want to impress your interviewer, if they ask you, tell me about the challenges that you have faced in your automation framework, then guys, you can really talk about the challenge which I'll be discussing in today's class. Okay. Now, over here, this is my whole browser utility, and to be honest, it is working properly. Okay. If I want to run my framework, I can just go to the terminal and I can write this particular command, maven test -d browser chrome -d is lambda test false, meaning I want to run the test on local machine, and -d is headless false, meaning the browser is going to be launched. -x, I have kept it over here because if I'm putting -x, my logs, the maven logs will be generated in detail. So I'm going to just hit enter. And in a moment, the test execution is going to get started. And this is really important that when you are having your framework, always have the habit of running it from the terminal. Why? Because if you're able to run it from the terminal, you can easily integrate it, right? You will notice that the test is getting launched and over here you're doing parallel execution. Multiple browsers are getting launched and it's executing all these tests. Okay. So what is the problem over here? Understand something. See guys, right now you will feel ki baba the test is executing, everything is working properly. But it is working properly because I have limited tests. Over here, how many tests I have written? 1, 2, 3, 4, 5. Imagine you were having 1,000 tests. Okay. Here I want to talk about scaling the framework. Okay. I'm just not going to talk about 5 tests or 10 tests. Let's say you have 1,000 tests. Now we want to make sure that if you're going to have 1,000 tests, the execution of your framework should still be fast. Okay, it should still be fast. So how we can do that? Will the code which I have written over here will work properly, or is it going to create some issues? Okay, spoiler alert, this particular browser utility which I have created is going to create a performance issue when you will try to run all the 1,000 tests, okay, over the CI and all. Now, understand something. What is this thread local variable? Make a note of this particular point. A lot of time in interview, they will ask you the question, what is this thread local variable, or how do you achieve parallel execution or multi-threading in your project? Now, obviously, if I am trying to run my test in parallel mode, multiple browser sessions are going to get launched. Parallel execution is happening, and each of your browser is getting controlled by one thread. Most of the time, when people are talking about parallel execution, they are just going to go to the testng.xml file and they are going to add a attribute called parallel equal to methods, right? And they'll also give a thread count like 8 thread counts, right? These are the two things that people generally talk about in interview. But understand something, you can also use something which is called as thread local. Over here, understand this part. We have some tests, okay? And these tests are working properly on my local computer, okay? So let's assume that we have 20 tests and the tests are running in sequentially, one thread, okay? And the execution is happening properly. All the test is passing, like all the tests, whatever you have written, it's pass. So you assume that it is going to work properly on the CI, but generally that is not going to be the case. In your CI pipeline, let's assume you have 100 plus tests, okay? And over there, you are going to do parallel execution. So 5 threads are, you're going to configure it that only, okay, 5 browser sessions needs to be created and all. But you will notice that one, you will end up getting random failures, okay? Failures which you did not get when you were running it on your local machine. But when you're running it over CI, okay, with your Jenkins or GitHub Action, you will start noticing that over there is some kind of a failure which is popping up. And you will also notice that the execution of your test suite takes a lot of time, okay, on your CI than on your computer. So we assume that the suite that we have created, okay, is slows down after 50 tests. Now, a lot of time, people are going to say that it would be because the tests are flaky. No, the tests are not flaky. It can be because of slow network. No, you don't have slow network. But the thing is, it is a performance issue of your code. Okay. So we need to understand the problem properly and then only we will be able to fix this particular problem. Okay. So the first thing over here that you want to understand is what is thread local variable. If I go back to the browser utility, you will notice that I have written thread local web driver equal to new thread local web driver, right? This is the line which I've written. I'm not writing web driver WD. It's a thread local. Now, what is ThreadLocal? ThreadLocal is basically a mechanism that gives each thread its own isolated variable copy. You want to do parallel execution, you want each of the thread to have its own browser session, right? You want each of the thread to have its own browser session. So how we will be doing that? We will make sure that each thread has its own WebDriver copy. Okay. So if I was making this as a normal variable in browser utility, instead of writing thread local, I would have written, let's say, private static WebDriver WD. Okay, something like this I would have written. Will I be able to achieve parallel execution? Yes or no? No. Why I won't be able to achieve parallel execution? You have made the variable as static. Static means what? Only one memory allocation. Only one memory allocation. Okay. And I want to have parallel execution. Multiple threads are going to run my test, and these tests are going to launch their respective browser. So what we do over here, guys, is we create thread local variable of WebDriver. Okay. And the benefit of that is that no two threads share the same variable. So WebDriver is created for thread 1, WebDriver is going to be created for thread 2 and thread 3. And each of my tests is going to be executed in isolation because of these threads. Now, this helps in avoiding conflicts in a multi-threaded environment. Okay. Now, I'm going to give you a very simple analogy. If you are using Git in your office, which I'm pretty sure you guys are doing that, every sprint, you guys create your own respective branches, right? You don't work on master or main. Okay, what you do, you create your own branch and you work on that particular branch. So when you create your own branch, what are you doing? You're creating your own local copy. And any modification, any changes that I do, any new files or any new code that I'm going to write, that is going to be reflected only in my local branches and not in the main branch, right? So this technically avoids conflict, right? A lot of time in interview they ask you, right? How do you ensure that there is going to be less merged conflict in your repository? Everyone do or use feature branches. Everyone work on their respective feature branches, and in this way, conflict can be reduced. Are you getting this particular point? So over here, we are using thread local variable because what it does is it avoids conflict in your multi-threaded environment. And the benefit that I get is it eliminates race condition, random failure, and ensures proper isolation of your test. You want that all your tests are executed in complete isolation. And that you can achieve when you're using thread local. I hope this part makes sense to everyone. Now, the syntax of thread local that you should remember. See, generally we write WebDriver WD is equal to new Chrome driver. Okay. But now I'm saying that WebDriver is going to be one of a variable which is going to be thread specific. So it should be created for thread 1, thread 2, thread 3. So over here, what we will be doing is we will be creating thread local of WebDriver type, which I'm going to call it as driver equal to new thread local WebDriver. And generally you used to write what? WebDriver WD is equal to new Chrome driver. Now I'm going to say driver dot set. We're going to get two methods. Driver is for your thread local, driver dot set, and to this set method, you're going to pass your WD reference. Okay, you can pass set or you can just create an object of new Chrome driver. And if you want to get the value of your WebDriver, technically you want to have your WebDriver session and all, you just do the driver.get. And it is going to give me the WD session, the WebDriver session that we are, the thread is currently using. Is this part making sense? Now, over here, how exactly the parallel execution happens? Understand this. Let's say the thread 1, thread 2, thread 3 are there. They are executing 3 different tests. There is going to be a login test, add new address test, and register user test. Now, these tests that we have, okay, they are going to have their respective web driver. They are going to have their respective web driver because web driver has become a thread local variable. So what is going to happen? Your thread 1 is going to use the web driver session, and this web driver session is going to control the login test. You're going to have thread 2, which is going to have its own web driver session, and it is going to execute your add new address test. Yeah, thread 3 is going to have its own web driver and it's going to execute your register user test. But in my code over here, there is one problem. I have created a web driver wait also. Okay. So there is a private web driver wait. This web driver wait which you see is not a thread local variable. Look at my code over here. Here you will notice that it is written private web driver wait. Is this a thread local variable? No. Meaning this variable is going to be shared across all the threads. So thread T1, T2, T3, they all will be sharing this particular variable. And when I'm saying sharing, it means they can read the value as well as they can update the value of this wait. So let's assume thread 1 uses the wait. For thread 1, technically, which is going to be the first process which is going to execute my test, it does not have any problem. It's going to run its test. Thread 2 does something crazy. What it does, it overwrites the value of wait. Over here, let's assume the value of the wait was 5 seconds. This chap, thread 2, overwrites it and makes it 10 seconds. Okay? 10 long value. And your thread 3 reads the wrong value. It's using the 10 seconds value. But thread 3 is running a test which requires a higher wait time. Meaning, let's assume it's going to require a wait time of 20. The maximum timeout time should be 20 seconds. But because thread 2 updated it to 10 seconds, okay, your thread 2 required 20 seconds. Because of that, this particular test is definitely going to fail. Are you getting the point? Now, any non-thread local variable accessed by multiple thread simultaneously, okay, is going to cause race condition. Okay, is going to cause a race condition. Race condition means what? One person is reading the value, other person is updating the value, other person is also updating the value. So who is going to update the value first? Okay, and technically it is going to result into conflict. Okay, because wherever the read operation is going to happen, it might read a wrong value. Okay, so read this particular line again, that any non-thread local variable, wait over here is a non-thread local variable, okay, accessed by multiple threads simultaneously. So this wait variable will be accessed by T1, T2 and T3. Okay, any non-thread local variable which is going to be accessed by multiple threads simultaneously is going to cause a race condition, and which is going to create random CI failures. Okay, this is important. This is important. You need to understand this part. That's the reason, you will notice that if you're running 5 tests sequentially, you will never face any problem. But if you start scaling your test, you start executing 1,000, 2,000 tests and all, somewhere down the lane, some tests pass, some tests fail, okay? Because what is happening is there are some variables, some data which is shared across all the multiple threads. Are you getting the point? Now, the thing is, we need to solve this particular problem, and this is the challenge. This is the challenge. Okay. So if they ask you in interview, what is the challenge that you have faced in your project? Don't just talk about dynamic locator. Don't just talk about synchronization issue. Okay. Talk in terms of real engineering problem. Are you getting the point over here? That you your tests were running properly when you were executing it on your local machine, but when you try to execute it on CI, there were some tests which were passing, some tests which were failing. Also, you noticed that the execution time on running the test on local machine was technically far less, or I would say was executing at a faster pace compared to what was happening on your CI. So CI used to take a lot of time to execute your test, and you had to solve this particular problem. So how did we solve this particular problem? We will be solving this particular problem by making your WebDriver wait as a thread local variable. Now, guys, understand something. See, in your automation framework, you will be making your WebDriver as thread local. Along with that, you're also going to make your WebDriver wait also as a thread local variable. These 2 points, please write it down in your notebook. If you really want to make sure that you're executing your project at you know, a higher scale, and you want to achieve proper parallel execution, the only way you can do that is when you are having your WebDriver and WebDriver wait as a thread local variable. Never ever in your automation framework, you'll just say WebDriver WD or WebDriver wait. Now, I have seen a lot of tutorials where just people say that, okay, they're going to create WebDriver WD and your WebDriver wait. They're going to run a couple of tests and all. But in reality, if you want to scale it off, it's not going to just happen with these two things. You are supposed to use thread local. All right. So that's the reason, like when you're giving interviews also, you are supposed to sound more like a consultant. Okay. You should understand the bigger picture. You're not just looking to run 5 tests in your entire automation test suite. No. You want to make sure that your entire framework is executing 1,000, 2,000 tests, and all these tests are running parallelly. Your execution time is as low as possible. Okay. Now, remember, whenever you will be using your WebDriver wait, okay, in your final version of your framework, it has to be thread local. So in my code, guys, where I have written WebDriver wait as wait, this line needs to get updated to private static thread local WebDriver wait, and I'm just going to create a thread local instance over here. Now, the only difference that happens when you create a thread local of a certain type is that you are supposed to use the set and the get method. Now, over here, if you notice, the old piece of code was what, and I believe everyone is aware of this, wait equal to new WebDriver wait, and you're going to give your driver instance. I have written driver.get. The reason I have written driver.get is because my driver is a thread local variable, and I'm giving duration of second 30. This code is going to get changed to wait.set because now I am initializing the wait for a particular thread. So I'm going to say wait.set, and here I will be creating the whole object. Okay. And in your automation framework also, you generally write wait.until expected condition visibility of element located by, and then you pass the locator and all, right. So this is what you write, wait.until. This chap is also going to be changed to wait.get. Wait.get. Once I get the wait instance, then I'm going to apply the until method. Okay. So the benefit over here, what we get is complete isolation. Your thread A calls wait.get. Okay. Your thread A is going to call wait.get. Thread A gets its own WebDriver wait, which is going to be untouched by all other threads. No thread is going to use thread A's WebDriver wait. Similarly, when thread B is calling wait.get, it is going to get its own WebDriver wait, which is going to be used for its own execution of the test. Okay. And in this way, we eliminate the race condition. This is important. Okay. This is important. So again, in interview, if they ask you the question, what were the challenges of your automation framework? Just to reiterate, I am telling this thing. One of the challenge that you can really talk about is thread safety. Okay. Previously in your automation framework, um, you were using, your normal WebDriver or your WebDriver wait. Okay. But the thing is, because you wanted to achieve parallel execution, you noticed that there were situations where you were having the race conditions. Okay. Race condition means what? A wait which is technically used by one of the thread is getting updated by other thread. So people, your threads are technically reading different values, because of which, okay, you are getting a random failure, and you were not able to isolate the test properly. Okay, because you want to do multi-threadings. Okay, you want to have all your respective threads running your respective test. Okay, you want your test to be isolated for the respective threads. In order to do that, you introduced ThreadLocal. Now, one of the thing that we do in ThreadLocal is that your WebDriver and WebDriver wait needs to be ThreadLocal variable. Okay, and if you are going to have any instance variable, I'm repeating, if you're going to have any instance variable, that instance variable, any non-thread local variable accessed by multiple threads simultaneously, your wait is becoming your instance variable. Okay. So it is a non-thread local variable. And if it is going to be accessed by multiple threads simultaneously, it is going to create a race condition and you're going to get a random CI failure popping up. To solve this particular problem that you were having these random issues and race condition, the only thing that you can do is you can make your WebDriver wait as well as your WebDriver as a thread local variable. So the issue was your WebDriver wait was not thread local, okay, and it was technically getting shared across all the threads. You are getting a race condition. So we solved it by making it as a thread local variable. Okay. Now there is one more thing that you should remember. Okay. In the browser utility now, I have this particular method called quit method. Okay. Generally, you write wd.quit to close the browser session. Okay. Understand this part carefully. In your automation framework, after some time, once the test is completed, you want that the browser which was open should get closed, right? So if you're going to use close, it is only going to close the respective tab. But if you're going to do a quit, quit is going to do what? It is going to close the complete browser session. So here I have written driver.get quit. Driver.get quit. Now this is going to close the session. Okay. The quit call, browser gets closed, the session gets closed. But there is a problem. Because we are using thread local, there is a dead driver that stays in the thread local memory. Okay. There is going to be a dead driver which is going to stay in the thread local memory. Your CI thread pool recycles thread 1 for test. Okay, let's say 51. But there will be 50 dead Chrome driver in the heap. So if there is, let's say, 51 test which is getting executed, there is technically going to be old 50 dead Chrome driver present in your heap memory. And GC pauses every few seconds. Okay, your garbage collector is going to get paused, okay, for few seconds. So because of this, that you have these dead sessions which is kept in the thread local memory, what is going to happen is that your test execution is going to become very slow. So your test suite slows down. Okay. And you probably might get out of memory error. Okay. And this is going to happen for, let's say, your 500 test and all those things. So over here, because we are using thread local, okay, and you want to quit your session, great, you are supposed to do that part. But after that, you are also supposed to remove it. Okay. Your Chrome driver, which is present in the thread local memory, that needs to be removed. And if you are not doing that, you will be having a memory leak. Okay. And because of this, your entire test execution is going to slow down. The execution is going to take a lot of time. So a quick fix that is there now, guys, is that you are supposed to call the remove method. You're doing driver.get web.quit, okay, to remove the session, great. But along with that, you need to make sure that your driver.remove is also happening, okay. And then because you're removing the driver, please make sure that you also remove the wait, because wait also we have created as a thread local, okay. So remember, if you're going to do driver.get.quit, you should also add driver.remove, and they work always together. Okay. You are not supposed to skip them. Okay. You just can't write one and forget about the other. So because if we are going to add driver.remove now, a no dead driver is going to get accumulated. There's no garbage collection pressure which is there. And the test suite is going to run at the same speed. Okay. Your execution speed is not going to slow down. There is going to be no memory leakage. Are you getting the point? So again, in interview, if they ask you what was the different challenge, so you can talk about the memory leakage issue also, that you were using the thread local variable and there was this quit method which closes the browser session. But because we were using the thread local, there was some dead Chrome driver or Edge driver instances which was kept in the thread local memory. And because of this, the GC used to slow down because it has a lot of instances, the dead instances that needs to be cleaned up to solve this particular stuff so that the performance of your framework does not slows down. Okay. And it is executing really, really fast. What did you do? Yes, you introduced just one extra line. You ensured that your thread local is also getting removed. Okay, so driver.remove and wait.remove was happening. I hope this particular part makes sense to everyone. Perfect. Now, the final thing, guys, again, this is just for your reference. I have written it off. How do you explain the whole stuff, whatever we have discussed in today's class? How do you explain all these things in interview? So let's say the interviewer asks you, Ki Baba, tell me about the challenges that you face in your automation framework. I know you will be talking about your locators, your dynamic web elements, probably going to talk about your web tables and all those things. Great. But add these things also. It's just going to help you present yourself as more technically sound. Okay. Now, in our browser utility class, test passed locally but failed randomly in the CI. After analyzing the thread dump, I found two root causes. The first one is that WebDriver wait was a plain instance variable and not a thread local variable. Thread raised on the same wait object, causing element not interactable exception at unpredictable time. Okay. Second, quit called the driver quit, but it did not remove the driver.remove. After 50 tests, there were dead WebDriver objects in the thread pool causing garbage collection pressure. And 40% was a slowdown in your execution of your entire test automation suite. And you fixed both. And you introduced wait, the WebDriver wait as a thread local, added driver.remove in the tier down. Okay. So every log line is tagged with the same thread. This is something that you would have done. Okay. Whenever you are answering the scenario driven question, you have to have a very specific problem. Okay. Add a very specific problem. Come up with a good story. Okay. Then you also talk about the root cause. What caused that particular problem? Okay. And what was the fix and the measurable outcome? Now, over here, probably I can just say that the execution time, which probably was, I don't know, let's say 15 minutes, we have brought it down to 5 minutes or something like that. So if you are able to present yourself, sounding properly, technically, it is definitely going to help you crack your interviews. So that's it, guys. That's it, what I had for today. Okay. It was a pretty different session, but I really hope that this particular session helped you out in all the possible way. Don't forget to mark your attendance. If you're interested in the notes, you're going to find it in the YouTube Tech with Jatin membership. Now I'm going to see you guys in the next one. Don't forget to mark your attendance. Till then, take care. Bye-bye.